Hello students, now we will discuss about working of wind power plants. Working of wind power plants. Wind is a form of kinetic energy created in part of by a sun. About 2% of sun's energy that reaches the earth is converted into wind energy. The atmosphere is heated during the day by the sun and at night it cools by losing its heat to space. Wind is the reaction of the atmosphere to the heating and cooling cycles as well as the rotation of the earth. Heat causes low pressure areas and the cool of the night results in high pressure areas. This process creates wind when air flows from high pressure areas into low pressure areas. Wind energy has been used for hundreds of years. The windmills of Europe and Asia converted the kinetic energy of the wind into mechanical energy, turning wheels to grind grain. Today, wind-driven generators are used to convert the kinetic energy of wind into electrical energy. Wind power is a clean and renewable energy source. It produces no pollution and it doesn't harm our earth. Also important is the fact that the price of the wind power is not affected by fuel price increases or supply disruptions. It is a domestic renewable energy source. The land used for wind turbines can still be used for other purposes such as grazing and farmland. Wind-driven systems consist of a tower to support the wind generator devices regulating generator voltage, propeller and hub systems, tail vane, a storage system to store electricity for use during the windless days, and a converter which converts the stored direct current and into electrical alternating current. Wind energy accounts for 6% of renewable energy electricity generation. The US wind energy industry achieved unprecedented success in the first year of the new century, installing nearly 1,700 megawatts or $1.7 billion worth of new generating capacity. Due to the continuing research and better placement of turbines, wind power has become much more reliable. Virtually all regions of Canada have areas with good wind resources. Oceans and large lakes, open prairie and certain hill or mountain areas often have good winds, and these areas are where Canada's current wind generation facilities are located. There are commercial wind turbines in 5 provinces and the Yukon with plans for further installations in almost all the rest of the provinces. Natural Resources Canada estimates that Canada has almost 30,000 megawatts of developable wind resource. This compares to their current installed base of 200 megawatts and would be enough to supply 15% of Canada's electricity supply. The wind energy futures looks bright and there is a growing interest in wind power within the North American electric industry. Working principle of wind turbine. There is an air turbine of large blades attached on the top of a supporting tower of sufficient height. When wind strikes on the turbine blades, the turbine rotates due to the design and alignment of rotor blades. The shaft of the turbine is coupled with an electrical generator. The output of the generator is collected through electric power cables. When the wind strikes the rotor blade starts rotating. The turbine rotor is connected to a high-speed gearbox. Gearbox transforms the rotor rotation from low speed to high speed. The high-speed shaft from the gearbox is coupled with the rotor of the generator and hence the electrical generator runs at a higher speed. An exciter is needed to give the required excitation to the magnetic coil of the generator field system so that it can generate the required electricity. The generated voltage at output terminals of the alternator is proportional to both the speed and field flex of the alternator. The exciter current is controlled by a turbine controller which senses the wind speed. Then output voltage of electrical generator is given to a rectifier where the alternator output gets rectified to DC. Then this rectified DC output is given to line converter unit to convert it into stabilized AC output, which is ultimately fed to either electrical transmission network or transmission grid with the help of step-up transformer. An extra unit is given used to give the power to internal auxiliaries of wind turbines. This is called internal supply unit, like motor, battery, etc. There are other two control mechanisms attached to a modern big wind turbine, controlling the orientation of the turbine blade. Another one is controlling the orientation of the turbine face. The orientation of turbine blades is governed from the base hub of the blades. The blades are attached to the central hub with the help of a rotating arrangement through gears and small electric motor or hydraulic rotatory system. The system can be electrically or mechanically controlled depending on its design. The blades are wheeled depending upon the speed of the wind. The technique is called pitch control. It provides the best possible orientation of the turbine blades along the direction of the wind to obtain optimized wind power. The orientation of the nozzle or the entire body of the turbine can follow the direction of changing wind direction to maximize mechanical energy harvesting from the wind. The direction of the wind along with its speed is sensed by an anemometer, that is automatic speed measuring devices with wind vanes attached to the backtop of the nozzle. The signal is fed back to an electronic microprocessor based controlling system which governs the yaw motor, which rotates the entire nozzle with gearing arrangement to face the air turbine along the direction of the wind. Thank you.